Imagine a lake, calm, serene, maybe a vital part of a community. Then, without any warning, it just explodes. But not with fire or lava. No, with an invisible deadly gas. This isn't science fiction. This really happened. Lake Mana in 1984, 37 people killed. And then Lake Nyos in 1986, over 1,700 lives lost. Both in Cameroon. And both, bizarrely, during the rainy season, almost exactly 2 years apart. It was this complete mystery, baffling scientists, devastating communities. So today we're taking a deep dive into this really extraordinary phenomenon. Our mission is to unpack the scientific debates, and believe me, they were intense around these killer lakes. We'll also delve into some fascinating local myths, stories that, well, might have actually foretold these disasters, and then we'll compare what modern science tells us with what anthropology uncovers.
Yeah, and what's so compelling, I think, is how you have this cutting-edge science, bumping up against centuries-old oral traditions. It reveals a really complex and, honestly, a truly compelling picture of, well, us and our environment.
Okay, let's get into it. So, Nyos happens, this terrible tragedy, and the scientific community immediately jumps on it, right? Debates kick off almost instantly. Two main ideas, two scenarios emerged to explain what happened. What was the first one?
Right, the first one is generally called the limnic hypothesis. Limnic just meaning lake-based. And it suggests that carbon dioxide, CO2, coming from deep magmatic sources, deep in the earth, it accumulates at really high concentrations in the deep water.
Okay.
But because the lake is stratified density layers, what we call meromictic conditions, this CO2-rich water basically gets trapped down at the bottom.
So it can't easily mix and release the gas normally.
Exactly. It just sits there building up pressure until something triggers a disruption.
So, like you said, it's kind of like a giant natural soda bottle just waiting to pop, highly unstable.
That's a great way to put it, yeah. And the triggers proposed, well, there were several. Landslides were a big one, seismic shocks, earthquakes, rock falls, even just internal water movements like waves deep down or maybe colder surface water sinking and causing an overturn.
Right, that makes sense.
For the 1984 Monon event, for instance, the thinking was it might have been an earthquake-induced landslide that set it off.
And the evidence for this limnic idea, it seems pretty strong on the surface.
Oh, definitely. You look at the water chemistry in lakes like Nyos and Monon, very high dissolved CO2, high ferrous iron, magnesium, calcium, bicarbonate, all that stuff. But, and this is key, really low levels of chloride and sulfate.
Okay, why is that significant?
Because high chloride and sulfate often point to direct input of volcanic gases. Low levels suggest the CO2 isn't bubbling straight in from a volcano. It's more likely the result of water interacting with rocks deep down, leaching the CO2 that way.
I see. Water-rock interaction, not direct venting.
Precisely. And then there's the temperature thing.
Right, you mentioned the lake temperature actually rose after the event. That seems counterintuitive.
It does at first, but think about it. When a dissolved gas rapidly comes out of solution like CO2 from water, it actually causes cooling. It's an endothermic process. So if the lake cooled significantly during the degassing, finding it slightly warmer afterwards makes sense as it returns to equilibrium, or maybe due to mixing, bringing up slightly warmer deep water.
Okay. That's clever.
Plus, surveys after the Nyos event found the water wasn't very turbid, not very muddy, and there wasn't strong evidence of the bottom being massively disturbed, which you'd probably expect from a big, violent volcanic eruption through the lake bottom.
Okay, so the limnic hypothesis sounds pretty comprehensive. Case closed.
Well, not quite. There was another major contender, the volcanic hypothesis.
Okay, so what's the angle there?
This view argues it wasn't gas slowly building up in the lake water. Instead, it was a more direct, sudden injection of gases from right beneath the lake floor. Almost like a phreatic eruption, that's where magma heats groundwater, causing a steam explosion. But here, it's mainly magmatic CO2 jetting directly into the lake.
So more like a sudden volcanic belch from underground, as some put it.
Exactly. A much more geologically violent and sudden event originating below the lake.
And what evidence supported this idea? Because the limnic one seemed pretty solid.
It did, but the volcanic hypothesis had strong points too. First, the isotopes. Carbon and helium isotopes in the gas very, very clearly pointed to a mantle origin, magmatic.
Okay, but wait, didn't the limnic proponents agree the gas source was ultimately magmatic, just that it seeped in slowly?
Yes, exactly. That's a crucial point. Everyone agreed the gas came from the mantle deep down. The debate wasn't where the gas came from, but how it got out.
Got it. Mechanism, not origin.
Yeah.
So what else for the volcanic view?
Volume. The estimated size of that deadly gas cloud was huge, around 1 cubic kilometer. Some argued that was just Way too much gas to have been stored solely within the lake water itself, maybe several times the lake's volume in gas.
Okay. That does sound like a lot.
They argued it was more consistent with a large external pulse of gas. Also, some initial reports, though, maybe debated later, suggested the lake surface was unusually warm immediately after, hinting at heating from hot volcanic gases bubbling through.
Interesting.
And there was some seismic activity recorded locally around the time. Plus, people observed ongoing activity afterwards, like months later, small gas emissions, reddish spots appearing in the lake, stuff like that.
Suggesting the system was still active underneath.
That was the interpretation, yes. Ongoing subsurface rumblings. One paper flat out said, our opinion is that the volcanic scenario accounts much better for the observations. So strong opinions on both sides.
Wow. Okay, so despite all this intense study, there wasn't total agreement.
That seems
Surprising for such a major disaster investigation.
It does, but it highlights something important about science, right? Especially with complex natural events. Complete consensus isn't always immediate or even possible on every detail.
So the origin of the gas magmatic agreed upon, but the release mechanism, degassing from the lake water or direct injection from below that, was the sticking point.
Precisely. And the devil was really in the details, in reconciling all the observations. Some things just fit one theory better than the other.
Like what? What were the main points of divergence?
Okay, take the skin lesions. Survivors reported these burns. The limnic model struggled with that. The lake water wasn't highly acidic. How do you get chemical burns from CO2-rich water?
Good question.
But the volcanic hypothesis could say, well, maybe acidic volcanic fluids from deeper down got carried up in that initial plume.
Plausible. What else?
The smells. People reported smells like rotten eggs, gunpowder.
Which suggests sulfur compounds, right? Hydrogen sulfide.
Exactly, H2S or other acid volcanic gases. The limnic scenario has trouble explaining those in high enough concentrations to be smelled over a wide area. CO2 itself can have a sort of sharp taste or smell at high levels, but these specific smells point elsewhere.
And the volcanic idea.
Easy explanation. Those gases are common deeper down in volcanic systems and could have been part of the injected mixture.
Okay, what about sounds? People reported hearing explosions, like gunfire, even the ground cracking.
Right. The volcanic folks could interpret ground cracking as linked to pressure changes from a deep intrusion, maybe subsurface adjustments. The limnic model has a harder time explaining loud explosion sounds coming from outside the lake itself. The degassing might make noise in the lake, but gunfire, ground cracking, harder to fit.
And the red stains on the lake.
Ah, yes. The reddish-brown color afterwards. Both sides had explanations. Limnic, it's oxidized iron. Deep lake water is often anoxic, full of dissolved ferrous iron, Fe2+. When it hits the air, it oxidizes to ferric iron, Fa3+, which is rusty red-brown. Makes sense. Volcanic could also be iron precipitation, maybe from hydrothermal input linked to the eruption. Some even argued the presence of iron, but the lack of sulfur or acid in the main lake water supported a volcanic origin, suggesting the nasty stuff came up in the plume but didn't permanently change the lake chemistry. It got complicated.
So it really sounds like different pieces of the puzzle.
Yeah.
Just pointed in different directions. No single clean answer fitting everything perfectly.
Exactly. And the conclusions from scientific conferences at the time acknowledge that. They basically said, look, complete agreement is rare in these situations. Science moves forward through argument, counter-argument, testing ideas. Maybe the early physical data leaned a bit towards the limnic view initially, but those detailed witness accounts, the smells, the sounds, the burns they provided, really strong arguments for the volcanic scenario, too. You couldn't just ignore them.
Fascinating. Okay, let's pivot now, away from the geology, the chemistry, towards something equally captivating, the stories of the local people, the grassfields communities.
Yes, this is where it gets incredibly interesting, because you find these myths, these legends, passed down for generations that seem to describe events remarkably similar to what happened at Lake Nyos. It's quite uncanny.
Tell us about that. There's this idea of maleficent water in their cosmology.
That's right. It's a core concept in Grassfield's folklore. Water isn't just good or bad. It has the potential for both. It's dualistic. Circumstances determine which side comes out.
And they classified lakes based on this.
They did. They had good lakes, usually stable, deep crater lakes, reliable sources for drinking, bathing, and then bad lakes, sometimes called transferring lakes. These were often shallower, maybe seasonal, and crucially believed to sometimes just disappear from one place and reappear somewhere
For
else.
transferring lakes. That sounds mythical.
It does, but geologically, you can see a potential link. Maybe these beliefs relate to lakes forming or shifting along unstable volcanic fault lines, changes in hydrology.
In this belief, this distinction between good and bad water, it wasn't just abstract folklore, was it? It had real-world consequences.
Absolutely profound consequences, the most significant one. Grassfields people traditionally did not settle right next to lakes. They preferred to build their homes several miles away.
Which answers a question scientists had, right?
Hmm.
Why was the Lake Nyos area, with its fertile volcanic soil, so sparsely populated?
Exactly. Anthropology provides the answer. Centuries of cultural practice rooted in these stories, these beliefs about the potential danger lurking in the water. Generations lived by this avoidance.
Incredible. So tell us one of these stories. The calm origin story sounds particularly relevant.
It really is. It's dramatic. It starts with a betrayal. The Fawn, the chief of the neighboring Bemesi people, betrays the Calm, leading to their destruction, often described involving fire.
Okay, so conflict sets the stage.
Yes, and the Calm Fawn plots this elaborate, posthumous revenge. He commits suicide, and legend says his body fluids magically form a new lake. Maggots from his decaying body become fish in this new lake.
Wow, okay. Gruesome but potent imagery.
And the Bemesi people, seeing this new lake teeming with fish, are delighted. They flock to it, settle near it, fish in it.
Uh-oh, setting themselves up.
Precisely. Then the lake enacts the fawn's revenge. Some versions say it sank, but crucially, a few older Calm tradition keepers specifically recounted that the lake first exploded before sinking.
Exploded.
Yes. In their description, it's startlingly specific.
How so?
These older Calm storytellers described water rising up out of the lake first, like a column, then falling back down, killing the Bemesi people around it.
That sounds eerily like the eyewitness accounts from Nyos in 1986. People described seeing a column of water shoot up.
It's an incredibly close parallel, isn't it? Hundreds of years apart, potentially.
Is there any physical evidence that lines up with this calm story?
Interestingly, yes, potentially. There's a large swampy area near Bemesi today that local people avoid, believed to be where the vengeful lake formed. There are also strange cracks or linear features on the ground nearby, which the Calm interpreted as tracks left by the event. Geologists later identified these as lineaments, basically, surface expressions of underlying geological fault lines.
Wow, so the landscape itself seems to hold echoes of the story.
It seems that way. And based on genealogies and oral history, this event is estimated to have happened maybe 200 or 300 years ago.
And did the story mention the time of year? Like the rainy season link with Manon and Nyos?
There was some debate within the tradition about the season, but yeah, internal clues and some tellings point towards the rainy season, again aligning with the modern disasters.
Just amazing. Are there other stories like this?
Yes, the Oku origin story is another powerful example. It involves the Oku and Kajem peoples living near a different crater lake, arguing over its ownership.
Another conflict involving a lake.
Right. A stranger, possibly a witch, stirs up trouble. The lake starts its maleficent activities. Both fawns, both chiefs, end up entering the lake. The Kajem fawn is killed. The Oku fawn emerges victorious, honored.
In the lake.
Soon after, Lake Oku is said to have left its bed, maybe overflowed, maybe exploded. The term is ambiguous, and destroyed most of the Kajem people and their villages.
Another destructive lake event tied to human conflict and judgment.
Exactly. And fascinatingly, the Oku people apparently interpreted this as the lake showing it wanted to belong to them. They still perform elaborate annual sacrifices to the lake today because of this belief.
So these stories, Calm and Oku, while different in specifics, seem to share some deep underlying themes.
Absolutely. This is where someone like the anthropologist Levi Strauss would talk about bundles of relationships or schemata underlying patterns. You see it in both. Two groups, conflict or evil introduced, some kind of building or settlement, then deaths, revenge, a transformation involving water. Then the lake itself transforms or acts destructively, causing more death, leading to migration, and finally, the surviving group reconstitutes itself elsewhere. Symbolically, despite the different characters and plots, they're telling a very similar story. Dangerous water drives migration and shapes society.
Just this consistent thread, this cultural memory of water's destructive potential running through the lore.
Precisely. A powerful, enduring motif shaped by their environment.
Okay, so now the really big question. We have the science, with its debates and data. We have these ancient resonant myths. How do they speak to each other? How do they inform or even validate one another?
Well, if you step back and look at the bigger picture, The anthropology really lends significant weight to what science was starting to suspect. That widespread belief in maleficent water, that ingrained practice of not settling near lakes, it strongly supports a scientific idea that these crater lakes in the grass fields aren't static. They might have a life cycle involving dramatic, sometimes dangerous changes. The folklore suggests people knew this on some level for centuries.
Like the cultural knowledge provided context, maybe even a warning that science later started to quantify.
Exactly. And you see specific overlaps. That exploding lake description in the calm story,
Wow.
it's just too close to the Nyos eyewitness accounts and the scientific models of the gas burst to be pure coincidence, many would argue.
Right.
The idea of transferring lakes in the folklore finds that echo in the geology of unstable fault lines.
Mm.
In anthropology, it explains the settlement patterns around Nyos that puzzled some observers initially. The people avoided it for reasons embedded in their history. So both disciplines, science and anthropology, seem to converge on the idea that there's likely a grain of historic truth embedded within these legends.
And the timing fits too, doesn't it? If the lakes are geologically young.
Yes, scientific dating suggests many of these crater lakes are only maybe 1,000 or 2,000 years old. That's well within the time frame of human settlement in the area. It's entirely plausible that the origins of these stories incorporate actual eyewitness accounts of earlier eruptions or similar events.
So the approaches are different, obviously. Science is looking for the how, right? The physics, the chemistry, the exact trigger mechanism.
Exactly. Science wants the physical process, whereas anthropology explores the why from a human perspective. What were the motivations? How did societies explain it? What cosmological framework did they use? The calm explanation for the lake explosion wasn't dissolved gas dynamics. It was the Fawn's successful revenge plot.
It's like explaining the parting of the Red Sea as a miracle versus, say, wind set down or seismic activity. Different explanatory frameworks.
Precisely. Different kinds of knowledge offering different but potentially equally valuable understandings of the same event.
It really underscores that, doesn't it? That sometimes the ancient stories might hold observational details or warnings that complement or even predate formal scientific understanding.
Definitely. And it's not a closed book either. This interplay throws up new questions. For example, could these lake events be part of a larger cycle? Maybe linked to volcanic activity that influenced the great Bantu migrations thousands of years ago? That challenges geologists to refine their understanding of lake cycles and volcanism in
Right.
the region.
And it challenges anthropologists and archaeologists to dig deeper into migration histories and settlement patterns, connecting them to environmental events.
Exactly. It feels like both sides are pushing each other to find more pieces of this incredibly complex historical and scientific puzzle.
What an incredible deep dive that was, just connecting these ancient mysteries with modern cutting-edge science.
Right.
From the sheer terrifying power of these gas-charged lakes to the wisdom that's just woven into the local myths. It's clear this story is still unfolding for the communities there and for the scientific world.
Absolutely. And that's the heart of it, isn't it? This profound interaction between human history, cultural memory, and raw geological forces. It reminds us that nature's cycles, even the dangerous ones, often echo in our oldest stories. They offer warnings, explanations, and maybe the key takeaway is that this kind of ancient wisdom, this human resilience, it's not just folklore. It can actually be a vital early warning system for hazard science, is still working to fully grasp.
Yeah, and the work continues today, doesn't it? Monitoring Lakes Nyos and Monon, trying to mitigate the risks. And that effort has to blend the latest science, limnology, volcanology, with a real understanding of the people, their history, their culture. Things like resettlement programs aren't just about drawing lines on a hazard map. They need deep sociocultural sensitivity. So what does this all mean for you listening? Maybe it's just a reminder to look at the stories around you, ancient, modern, whatever, with a slightly different lens. Look for those unexpected links between human experience and the natural world we inhabit.
And maybe consider how knowledge, wherever it comes from, science, tradition, personal experience, can be crucial for our safety, for our understanding. It leaves us with a big question, I think. What other historical events, maybe long dismissed as just myth or folklore, might actually hold crucial factual insights into the natural hazards we still face today?
A powerful thought to end on. Until next time, keep digging, keep questioning, and keep exploring.